Okay, let's talk about three different types of functions: injection, surjection, and bijection. So let's go back to our definition of a function. So if we have f is a mapping from x to y, and remember, from x, let's do that down there, each member in the domain x must uniquely map to a member of the range y. So you can't do 2 mapping to b and c, because that's not a rule. If you have f of 2, which one does it go to now? Does it go to b or does it go to c? You can't know which. So that is not a function. To have a rule, they must uniquely map. Now, 3 can map to b, because then I know that f of 2 is b and f of 3 is b. So that's allowed, but you can't function. Each item in the domain must map to a unique item in the range. All right, each member. An injection, let me write this up here. Each member of the range is mapped to by at most one member of the domain. So there, and there. This is D is mapped to by 1, B is mapped to by 1, C is mapped to by none, but that's okay. We said at most 1, and A is mapped to by 1. So this is an injection. The formal definition for an injection is for all A and B in set X. If f of A equals f of B, then A equals B, which means it's the same. So that's saying the only way that f of f of 1 is going to be D. The only way that that this could be D is if you're doing f of 1. So A must equal B. It's actually much easier to understand in the intuitive definition than the formal definition, but the formal definition is useful for proving things later on. Yes, that is an injection. By the way, this is also called 1, 2, 1, right? And that definition makes sense, right? There's only one element of the domain that maps to one element of the range. Okay, now if we have a surjection, this means that there are no gaps in the mapping. So every element of the range is mapped to at least once. So in this case, every element of the range y is mapped to by some element of the domain x. There are no gaps is essentially what it means when it's surjective. The formal definition, actually let's say for all b that are members of set y, there exists some a that's a member of set x such that b equals f of a, right? That's the formal definition. For everything in set y, there's something that makes it true. This is also called onto, right? So the other one was also called 1-to-1. This is called onto. That is, the entire range is mapped onto. Now, remember our definition for image before. An image are the actual items within the range that are mapped to. What you should notice in a surjection, the image is the range. They match up. So D, B, and C are both the range and the image in this case. Now our last type of function is called a bijection. And a bijection is both onto and 1-to-1. It is both an injection and a surjection. And that just means that every element in the range is mapped to by some element of the domain, and they are mapped to at least once, right? So every element of the domain is mapped to by at least some element of the range. Each element of the range is mapped to by at least one element of the domain, and they are mapped to at most once. And the key thing about a bijection is it is reversible. So I can also reverse that mapping. I can't do that in all of our prior cases, right? Because remember, a function, each member of the domain can map to only one member of the range. With a surjection, I can't reverse that function. Here I could reverse the x and the y and create a new function based on that. So our formal definition of a bijection is just our definition of a surjection and a definition of our injection ANDed together. I'm not going to write them out again. Okay, one last thing I want to talk about. Let's say that we have, suppose we have some set A, and A has the values 1, 2, and 3. And let's say that we have some function f that maps from A to A. That means the domain is 1, 2, 3, the range is 1, 2, 3. Remember, we could also write this that f is a member of A to A. We call function f here a permutation because essentially we could write, I'm going to give you a definition here. F is, that's supposed to be a parenthesis, 2, 3, 1. And what we've essentially done is taken 1, 2, 3 and replaced them with those values. We've scrambled them. It's a permutation. That's what we mean when we say a permutation. So a permutation is a function that maps to itself and is a bijection. Why does it have to be a bijection? Because if it wasn't a bijection, we wouldn't have every element of the range pop up exactly once. That's why that is why it has to be a bijection. Right? So permutation is a function that maps a domain to itself. The domain and the range are the same, and it is a bijection. This comes up all the time in cryptography when you're scrambling things together. When you're scrambling a signal, you generate a permutation of it. Okay, and I should write that term at the top. A permutation. If you have any questions about any of these definitions, ask in the forum below.